Whoa. Listen to me. I'm dropping buzzwords faster than a Butterfinger juggler drops plates. Let's slow down for a minute and talk about some definitions. The systems we're talking about can be polling systems. A polling system is one way in which several terminals can share a common data line. Each terminal can be selected individually when the host wants to output data. In addition, each terminal is interrogated or polled periodically by the host to see if it needs service. Now, did you notice that I used the word polling in two ways there? In one sense, there are the two processes of polling and selecting. Polling takes place when the host says, terminal so-and-so, do you have any data to send? When the host says, terminal so-and-so, here's some data for you, that's selection. Now, the other sense in which we use the word polling is when we talk about polling systems. It's a polling system when we use the process of polling and selection to permit several terminals to share the same data line. Okay, the polling or selecting is accomplished by means of the address information. That information is encoded or interpreted by devices on either end of the data line. On the computer end, it's the front-end controller, or TCU. On the terminal end, it's the remote controller. Some of the terms applied to polling systems mean different things to different people. Remember word and byte in the first program in the series? Well, there are other terms you'll have to watch out for as well. One of those terms is multi-drop. Often people will say multi-drop when they refer to any system with multiple terminals on a single data line. More precisely, however, multi-drop refers only to systems with multiple controllers. Properly speaking, a polling system with a single controller and multiple terminals is a cluster. But it isn't that simple. Some people will insist that a cluster means only a particular way of feeding several terminals from a single controller, with a separate line for each. They'll tell you that if you put all your terminals on a current loop, you have a chain. Is a chain also a cluster? Well, it depends on whom you talk to. Hardware definitions are a little more clear-cut. That remote controller is the device that connects to the modem on the terminal end of the data line and directs data to and from the terminals in the cluster, or chain. It can be a separate piece of equipment, as it is in most IBM installations, or it can be incorporated as part of one of the terminals, as in some Tektronix 4025 installations. The front-end controller, or transmission control unit, as IBM refers to it, is on the other end of the line, between the modem at the host end and the host computer itself. The programmer runs a program on the host and downloads its output to the front-end controller to define the port. Now, what about half duplex and full duplex? Is there a difference between asynchronous and synchronous here? The answer is yes, there is. And it's important to understand. On normal phone lines, that is single-circuit two-wire lines, synchronous modems operate only in half duplex. That is, only one modem can send at a time. Full duplex synchronous modems require 4 wire lines. Now, as I mentioned earlier, some synchronous modems are self-clocking. They provide the clocking signals to the TCU or to the controller over lines in the RS-232 interface. Well, that's all theory. Let's see how a real-life synchronous system might go together. The mainframe could be a CDC or a Honeywell or whatever, but let's stick with IBM for our examples. We'll postulate a 370 Model 168 mainframe. The terminal control unit on this is most likely a Model 3705 or something like it. The IBM 3705 is a programmable TCU that can handle a variety of different terminal devices and protocols. In a data entry application, you'd find a port defined for an IBM 3271 controller. That can feed a cluster of IBM 3277 alphanumeric terminals. In fact, that's just what you have in the tech order processing department. Now, even though that TCU port is defined for that IBM controller, That doesn't mean you can't connect something else out there. For example, you could connect a Tektronix 4025 with its option 11 controller instead of the IBM 3271. That 4025 with option 11 could then feed a chain of up to 7 additional 4025s and 4024s. The advantage to someone using such a system would be that the 4025s in the chain would be able to do graphics, something that was impossible with the IBM controller and terminals. There would have to be some enhancements in the applications program in the mainframe. These would be necessary to take advantage of the differences between the Tech terminals and the IBM terminals. But there would be no change in the way the port was defined for the TCU. In other words, the communications protocol remains the same. Now, watch out for that current loop connecting the terminals, though. Don't try to use it to drive peripherals. It's only for those terminals. If you want to use a peripheral, connect it to a 4025 over a separate interface. While we're talking about hardware out in the real world, let me digress for a minute. What I have to say deals with asynchronous rather than synchronous communication, but it fits into the program at this point very well. A great many real-world installations use Tektronix 4010 series terminals communicating over data lines with IBM 3705 TCUs. There are two kinds of ports that can be defined in 3705 for the Tech terminals. A 4010 with the data communications interface would require a port defined with ASCII code. Tech has special routines for the IBM 3705 to enhance normal ASCII communications as required by our terminals. If a 4012 were equipped with an option 22 interface, the IBM TCU can have a port defined so that it treats the Tech terminal as if it were an IBM 2741. The data code in this case is neither ASCII nor IBCDIC, but another IBM code called correspondence code. Let me emphasize again, Tech 4010 series terminals are strictly asynchronous. I'm mentioning them here in this program on synchronous communication because they're frequently used with a very commonly encountered front-end controller that can have ports defined for both asynchronous and synchronous communication. Well, by now you should understand something of synchronous data communication. You should be able to describe how a message is broken into blocks and encoded, and you should be able to describe the necessary hardware and define some terms. To understand a synchronous system and to be able to decide if a piece of hardware is compatible with a particular system, you must understand the system protocol. I hope the material in this program helps you to do that.
Great, Matt. Thank you. Security, though, says your car is